Hello guys, so today we are going to solve two more standard functions in this video, that is y equal to sine of ax plus b and y equal to cos of ax plus b. Let us go to the first step, that is y1 is equal to d by dx of sine of ax plus b. We know that d by dx of sine x is equal to cos x. So with the help of this formula, by considering this ax plus b as x, if we do the derivation, we'll get as cos of ax plus b, but we know that this is not in the x form, so we have to do the derivation again, that is d by dx of ax plus b. So it can be written as again cos of ax plus b into d by dx of x becomes 1 and the b is constant, so it becomes 0, so it can be written as into a. Now again it becomes a into cos of ax plus b. But if you see clearly, the derivation of this first derivation is not in the form of sine. I mean, if you have to derive the pattern to determine the antiderivative from this derivation, we need to convert this cos into sine theta to have a same pattern from y and y1 and y2 and so on. To convert this, we have one more formula, that is cos theta is equal to sine of 90 plus theta. It also can be written as sine of pi by 2 plus theta. With the help of this formula, if we convert this, we will get as a into sine of pi by 2 plus ax plus b, by considering this ax plus b as theta. Now let us derive for the second step, that is y2 is equal to d by dx, by considering a as constant, sine of pi by 2 plus of ax plus b. We know that derivation of sine theta will become cos theta, so it can be written as a into cos of pi by 2 plus ax plus b. But we know that this is not in the x form, we have to derive this again as d by dx of pi by 2 plus ax plus b. So it will become again a into cos of pi by 2 plus ax plus b, and derivation of constant will become 0 and it also 0, but derivation with respect to x becomes 1. So the finally we'll get as a. See again, it is not in the pattern as like before. I mean, it is not in the sine form, so we have to convert it into sine again, and also we have to multiply this a into a. That is with the help of similar formula, that is cos theta equal to sine of pi by 2 plus theta. So it will become as a square into sine of pi by 2 plus of this one pi by 2 plus ax plus b. So if we add this pi by 2 and pi by 2, we will get as 2 pi by 2, a square into sine of 2 pi by 2 plus of ax plus b. But one more thing here guys, don't cancel this 2 and 2 because we need to derive the pattern with the help of this. So similarly we will get the y3 as, with the help of same pattern, a cube into sine of 3 pi by 2 plus ax plus b. Similarly, y4 can be written as a power 4 into sine of 4 into pi by 2 plus ax plus b. With the help of similar pattern, we can derive antiderivative as yn is equal to a power n into sine of n into pi by 2 plus ax plus b. Now let us go for the second question, that is y equal to cos of ax plus b. If we go for the step 1, that is y1 is equal to d by dx of cos of ax plus b. We all know that the derivation of cos x is equal to minus sin x. With the help of that formula, by considering this whole ax plus b as x, if we do the derivation, we will get as minus sine of ax plus b. And all we know that it is not in the x form, so we have to do the derivation again. So it will become finally as minus sine of ax plus b into d by dx of ax will become a, because this x is 1 with respect to x and constant b equal to 0. Now if we see, consider this derived function is not in the form of constants, so we have to again convert this into constant to have the similar pattern to derive the antiderivation for this standard function. So with the help of one formula, that is minus sine x is equal to cos of pi by 2 plus x. So with the help of this formula, by considering this x as ax plus b, it can be converted as cos of pi by 2 plus of ax plus b into a. Now let us derive for the second term, that is second time derivation, as d by dx of cos of pi by 2 plus of ax plus b into a. We know that a is constant, so we will bring it to the front, and the derivation of cos theta is minus sin x, that is minus sin of pi by 2 plus of ax plus b. We all know that this is not in the x form, so we have to derive again, that is d by dx of pi by 2 plus of ax plus b. Derivation with respect to x, this x will becomes 1 and b becomes constant because b is constant, and also pi by 2 is also constant, so it will become 0. So finally we will get as a into minus sin of pi by 2 plus ax plus b into a. By multiplying this a into a, we will get as a square into minus sin of pi by 2 plus ax plus b. We know that this derivation is not in the cos form, so we have to again convert with the similar formula, that is minus sin theta is equal to cos of pi by 2 plus theta. With the help of this formula, by considering this theta as pi by 2 plus ax plus b, we will return it as again a square into cos of pi by 2 plus ax plus b. So now add this pi by 2 into pi by 2, so it will become 2 pi by 2, a square into cos of 2 pi by 2 plus ax plus b. Similarly, we can derive the y3 as, with the help of same pattern, a cube into cos of 3 into pi by 2 plus ax plus b. Similarly, we can written y4 also as a power 4 into cos of 4 into pi by 2 plus ax plus b. So finally, with the help of similar pattern, we can derive integration, that is yn equal to a power n into cos of n into pi by 2 plus ax plus b. So that's all about today's video. Thanks for watching.